All right, another set of identities that's quite useful are the negative angle identities. And let's start looking at them here in some justification for those by looking at the graph of each individual function. So here I'm looking at the sine of x, and the identity that we have is that the negative angle identity says that the sine of x is the same, well, how about the sine of negative x? The sine of the opposite of x is minus the sine of x. And we can see that here in the graph, that if you go out to, say, some distance here, if I go to, let's see, how about this point right there? That's about 1. On the x-axis, I look at the sine of 1. Well, the sine of 1 would be this height here is our sine of 1. And let's see, that's 0.5, 6, 7, 8, about 8.5 roughly. Sine of 1 is about 8.5. But if you also look at negative 1 would be about this point. If you look at the height on this axis, it's the opposite of that. It's the same size, but opposite in sign. It's the same value of values, but it's the opposite that we have in sign. So here, the sine of 1 is about, what did we say, about 0.85 roughly, and the sine of negative 1 is about minus 0.85. And if you look at any value you want, if you want to look at, say, the sine of negative 4, well, negative 4 is here, and so our sine value would be this height, 0.567, 0.7 roughly, 0.77 roughly speaking. And then if you look at the sine of positive 4, so if I go to positive 4 on the x-axis, and if you compare the height here we have at 4 with the height at negative 4, this one's going to be a negative 0.77. So that you get that the sine of negative 4 is the opposite of the sine of 4. And that's true for any angle that you look at, anywhere you go on that sine curve, wherever you look on that sine curve. If you come out here to 6, negative 6, you've got a height here of about 0.3. And over here at positive 6, you got a height of negative 0.3. So the heights are the same height, they're just the opposite in sign. So we have this relationship that the sine of minus x is equal to minus the sine of x. You can also see that from the unit circle. Let me clear out all those drawings and hop over to the unit circle. Got to grab the pointer instead of the pen. We've also talked, so this is a circle of radius 1. And we've talked about how if you take some sort of angle, whatever angle that you want here, and you look at the ray that you get if you go through an angle theta, we know that the y coordinate here versus if you go minus theta, take that same angle but go in the opposite direction, you should end up at minus y, the same number value, but just in the opposite direction. And that's true whatever angle you go at. If you take a positive angle, our sine value would be the vertical height here. It's, again, sine was of theta is the ratio of y over r. And in this case, I'm looking at a radius of 1. I've got a circle of radius 1. So the y coordinate is the same as the sine value. So our sine value here at a positive angle, if I go that same angle in the opposite direction, I should end up at, a little messy there, but I should end up with the opposite. The y values here are the same size, but they're opposite in sign. So, if this one is positive 0.2, it looks like, then this one here is a negative 0.2. So the sine of theta versus the sine of minus theta, sine of theta would be 0.2, and then the sine of the negative theta would be negative 0.2. In there, it's going to be the opposite value. If you go around the other direction, you're going to get the same thing. So we get that relationship in there that the sine of theta is equal to the opposite of the sine of theta. So I get positive 0.2 there. So if we go back and look at the cosine function, let's go take a look at the cosine function. Let's turn off. Get that out of my way. Come on, get out of my way. Turn on the cosine function and turn off the sine function. If you come out some distance along the x-axis, oh, I need my annotate picture, need my finger again. There we are. Need my pen to draw. If you come out some distance along the x-axis to here, and you look at what the y value here is, the cosine. So cosine of, well, that's cosine of 1. And if I look at the cosine of -1, if I go a distance out here, -1 on the x-axis, what are you seeing here? That the y values are exactly the same. So we have the identity that the cosine of -x is the same as the cosine of x. That if you have a negative angle or a positive angle, the cosine turns out to be the exact same thing in there. If I look at cosine of 4 is this distance, and the cosine of -4 is that exact same distance. They're both negative. They both have the same value there in there. So we know that the cosine of 4 is equal to the cosine of -4. Cosine of -1 is the same as the cosine of 1. If you go all the way out here to 8, -8, I got a cosine here of about negative, so maybe the cosine of -8, I might say, is a negative point, about point 1, I don't know, 0.15 or something like that, approximately. And then if you go over here to +8, cosine of +8, if I go over here at +8 and look, we've got about the exact same y value there. We got another value of negative 0.15. They're the same size and the same sign. So cosine of -x is equal to minus cosine of x is another trig identity. If you've ever got a negative angle and you want to switch the sign on that, that's a nice relationship. We can go back to the unit circle and see if that's the case on the unit circle too. So, I need pointer. There's the pointer instead of the drawer thing. If you take an angle, again, if you're looking at the unit circle, if you take some sort of angle in there, let's draw an actual line. If you go through some angle here, whatever angle you want of theta, oops, I'm drawing lines, not curves now. So if I take some angle theta, the cosine of theta was defined to be the x-coordinate divided by the radius. And here my radius is 1. I'm looking at the unit circle. We're 1 unit out here on the x-axis, 1 unit on the y-axis in there. So I'm looking at the cosine is just going to be x divided by 1. So it's just going to be the x-coordinate. So if I go to some angle theta, and I look here at what the x-coordinate is going to be, that's going to be the cosine of theta. But if you take the same angle but go in the opposite direction, if I went to net minus theta out here to the curve, my lines aren't turning out very straight, but I hope you're realizing that it's the exact same value, that the x-coordinate is going to be the same, whether you go clockwise or counterclockwise. If you go to some angle around over here versus going to that same angle the other direction, got on the wrong button again. Okay. The x-coordinate is going to be the same in both of those cases. The cosine is going to be the same, whether you're going in a positive direction or a negative direction. So we get, again, a verification that push the wrong button there. We get the cosine of minus theta is equal to the cosine of theta. All right, cosine of minus theta and cosine of theta. So the angle, whether the sign in the middle is positive or negative, it doesn't really matter. You're going to get the same output from that cosine function. All right, how about tangent? Let's go look at tangent. Our tangent graph. I want that one to go away. Come on, turn off that one. Turn off tangent, turn on tangent. So here's our tangent graph. Let me clear out all those annotations again. All right. Well, this one's a little, let me change the scale here a little bit on this one, make our life a little bit easier. Um, let's make our y-axis much larger. Let's go from, say, negative 20 to 20 there on the y-axis. Oops, I got two negatives. There we are, negative 20 to 20. So we get that more of that curve showing up in there. What's the relationship here? If you come out some distance along the x-axis, any distance you want on the x-axis. Well, I moved my pen down here at the bottom. So if I come out some distance from the origin, if you go out some distance here and you look at what is the tangent value versus going that same direction the other distance. Whoops, I only went 2 units there. 2 units the other direction. The relationship between this distance and this distance is, well, they're the same size, they're just opposite in sign. So with the tangent function, we get that the tangent of minus x is equal to minus the tangent of x in there, that we're getting that relationship as well. So that if you've got a negative angle, that you can bring that negative outside the tangent. And we can also get that from the sine and cosine. I know that the tangent of minus x is going to be the sine of that same angle divided by the cosine of that same angle. And I know with the sine, I can bring that negative sign outside. That's going to be the same as the sine of x. And cosine, I can just drop the negative. The negative doesn't matter. Cosine of minus x is the same as cosine of x. And so what I end up with there is just minus the tangent of x, because sine of x divided by cosine of x. When these angles degree, we can call that the tangent of x in there. So another way to verify a little proof, if you know the sine and cosine, you can get the tangent is the minus. But we can also see it graphically. What do you think about 1 over sine? What do you think about secant? What about secant? If I look at my secant graph here, turn off tangent. Turn off tangent. There, tangent's off. What about that one? Let's recenter that. Okay, there we are. Here's the secant graph, or this cosecant. Sorry, this is cosecant. What does it look like if you come out some distance along the x-axis and look at our curve values? And if I come out 1.5 units this way versus 1.5 units that way, looks like our y values are really close to being the same thing. Why is it fading away? I don't understand. Anyway, but if you come out a certain distance this way, the y value is the same size but opposite in direction. So we get the relationship with cosecant that secant of, I made mine disappearing ink. That must be the disappearing ink one. Okay. That's the not sine, cosecant. Cosecant. Cosecant, that if I take cosecant of minus x, that's going to be minus the cosecant of x. Okay. If you go out, out to 2 versus 2 in the negative direction, the y values are exactly the same. A little bit more than, let's see, 1.2 is that 1.3, 1 point something? Oh, that's 1.5. So yeah, 1.1, 1.2, something like that, and negative 1.1, negative 1.2 over here on the cosecant side of things. The cosine, cosine 1, or 1 over cosine the secant, if you travel out some distance in the x direction versus going the same direction in the negative direction, I go all the way out to 4 versus negative 4. What are we seeing about the y values here on the cosecant function? Here we are, 1, or yeah, it is 1 versus 1. What are the y values? How do the y values compare? Where they're the same thing. So for the secant of minus x is the same as the secant of x. There's no difference in there. All right. So secant and cosecant, or secant and cosine, the negative sign inside, whether you're doing your angle in the negative direction or the positive direction, doesn't matter. The secant value turns out to be the same either way. The others, if I look at cotangent here, grab cotangent and make cosecant go away. I guess cotangent's built in there. I wonder if probably the other ones are too. What do we see here? If you come out some distance on the x axis, come out like, how about that many units out? I got a positive value. If I go the same 2 squares out in the negative direction, I've got a negative value, but the heights are the same. If I come all the way out to 2, I've got a negative value on this side. If I come all the way out to 2, I've got a positive value on that side, but they are the same size. If I go 2.5 or even 3, well, 3 is really big down here, isn't it? 3 is really big, but if I go to 3 here, I'm getting that same size, just opposite in sign. So for cotangent of minus at t is the same as the cotangent of t. Cotangent, not cosine, cotangent is minus the cotangent of t. So we have trig identities there, another set with the negative angles in there. Everything changes sign, cosine of, except for cosine and secant, cosine and cosecant. That negative sign just disappears, but with cotangent, all of the other ones, if you've got a negative angle there, you could bring that negative outside and swap the sign of that angle, switch it over to the other value.